Dr. Benukar Biswas from Bidhan Chandra Krishi Vishwavidyalaya. So may I request Dr. Benukar Biswas to really appear and start his presentation. Mr. Benukar, are you here?
Yes, sir.
Please go ahead.
Thank you, sir. Respected Dr. Rashid sir, Director, SARC Agriculture Committee, Dr. Sikandar Khan Tanvi sir, Madam Taslima, and respected Chairman, Dr. Kabir sir, and all learned scientists of this SARC region. I'd like to express my sincere gratitude for the opportunity to share our experience on agroforestry in relation to regenerative agriculture in this August regional consultation meeting. As all of you know, to generate a recommendation in agroforestry, we need at least 10 years as gestation period. So I'd like to take the opportunity to introduce our team, because we are going to present some of our experience that has been started by our seniors right 15 or 10 years ago. And I am simply carrying the rich legacy of my predecessors. So here in blue colors are my teachers, guides, and my senior scientists: Devashish Chakraborty, Jagadish Timshina sir, Pratap Kumar Dhara sir, Deepak Kumar Ghosh sir, Arindam Sarkar, Vikas Ranjan Rai, Professor Rajendra Prasad sir of IASRI New Delhi, as well as my unputdownable young student brigade, Mousumi, Saju, Sohaili, Udayan, Kiranmoy, Sukumal, for their sincere efforts. Right from 5,000 years back, an Indian philosopher expressed his concern, saying that if we die, we are buried in soil. If soil dies, already UNESCO once said that 90% of earthland could be degraded by 2050. In our Indian experience, we have already lost 30 million healthy land, and there is a predict already another 120 million hectares, that is 36%, more than 36% of Indian land is prone to degradation, as depicted by satellite data and ground truthing. The horrific data from UNCCD in 2019, sir, 100 million hectares per year, that twice the area of Greenland has been degraded during 2015 to 19, resulting in a nexus of nutritional insecurity driven poverty and land degradation, with 750 million peoples with severe food insecurity, and many of them going bed in the night with empty stomach. And this is the gift from industrial agriculture, with their extractivist and productionist ideas and discourses that resulted these socio-ecological threats. And there are some sustainable agricultural narratives, as already expressed by earlier presenters, that organic agriculture, agroecology, conservation agriculture, sustainable intensification, and so on. And some critics say these are old wine in new bottle. I say no, this is the garland of the flowers of better experience of our earlier narrative. Their overlaps and the potential gap through which the new concept of regenerative agriculture has emerged and gaining popularity since 2015 in the both in academia as well as general media. Most of them, I think you have shown the film Kiss the Ground, that has really aroused a consensus about regenerative agriculture, which is simply a holistic farming system to improve quality of water and air, enhancing ecosystem biodiversity, so that we can produce nutrient-dense food in a sustained manner by storing more carbon and helping climate change mitigations. Following the practices, what already told, no tillage, cover cropping, intensive rotational grazing, crop livestock integration, use of organics, crop rotation, and agroforestry. Yes, what Devashish sir in the keynote address told about RA and soil health, and it is only not soil health, sir. It is the plant health, human health, animal health, and overall ecosystem health. What we used to say now, who and fowl-tailed One Health joint plan of action. Through introduction of biodiversity, it is possible in agroforestry. And it is a new technology that should not only be, it will be ecologically sound, but it will be economically viable too. And that potential we have in agroforestry. As all of you know, agroforestry is a deliberate inclusion of a forest species in existing agricultural crops or animals to enhance the land use efficiency in a sustained manner to improve above ground and below ground environment. If forest species is integrated with agriculture, we say agrisilvi system. If it is integrated with livestock, then silvi-pastural. And if three systems are in the same model, then agrisilvipastural model. It is the classic classification of agroforestry systems based on composition. And these are the some models we are maintaining at All India Coordinated Research Project Farm at Jhargram, West Bengal, apiculture with Kadam, agrisilviculture models, agrisilvi-horticulture models. Here one of my students, Udayan, showed that improvement of soil health through fruit-based agriculture, agroforestry system. Now boundary plantation with lombu, block plantation, energy plantation, alley cropping, silvi-horticulture, horticulture, and it is the homestead agroforestry. The example of Bangladesh shows to the world the art and science of increasing livelihood without deteriorating soil health and improving environment quality. This is the learning and teachings of Bangladesh, this homestead agroforestry, and they have how with the limited less they can produce more in a sustained manner. This is the teaching from Bangladesh. Now agroforestry in regenerative agriculture, it is the one of the sustainable pathway for crop production. Just if you can see that in monoculture, this is the yield level. Now we introduce 2 rows of forest crops. Nearer to forest crop, in the rows of alley cropping, there is a zone of competition for light, water, nutrient, and space, resulting some yield penalty. And there is also, we have selected the alley crop in such a way, there will be a complementarity too, in the form of fertility build-up, microclimate, congenial microclimate development, checking erosion, nutrient pumping, safety net, tree biomass, and soil carbon stock improvement. So here we are getting some yield advantage. Now these are the area where we are also compromising some area of alley crops. Now, what will be the strategy to improve the net benefit over monocropping? If we add value to the tree crops, if we select alley crops in such a way so that the competition will be as less as possible and the complementarity will be as more as possible. Sorry. And here, this is a multi-story hedgerow system where there is a scope of improving value of the trees. Here rubber and timber with deep root system provide anchorage, then banana to enhance livelihood support. And in this strip, to avoid erosion, we are using 2 double-day Sitaria grass with their dense root system to bind surface soils. Here, groundnut and maize, as well as site-specific fruit trees for enhancing the profitability of the system. Here we can use legume tree to harvest more atmospheric nitrogen. We can select fast growing multi-purpose trees too for harvesting higher carbon dioxide. And this is a system, this is a tree hedgerow with 2 grass strips in vegetable agroforestry system to enhance the complementarity effect among the component crops with conducing microclimate development, just like cocoa and coffee with rubber, or in tea plantation we use different shade trees. Elivich et al. In 2018, they proposed a regenerative agroforestry standard with a criteria integration having more than 40% tree shrub cover. Second is the density, more than 5 woody perennials within 100 meters square to ensure soil cover and nutrient cycling and weed control. Third criteria is multi-story to harness the complementarity among canopies as well as below ground root layers, accommodating more than 2 woody layers within 200 meters square. And the biodiversity with more than 8 plant types species within 100 meters to calculate the higher biodiversity. Advantage, as all of you know, environmental, economic and social. In our experience at Salboni, in a tribal village, adopting cashew-based agroforestry, we have promoted the profession of a migratory labor to farmer. And from last year, they have also learned the nursery techniques, and now they are going to become an entrepreneur too. There are some constants too in agroforestry. The depression of crop yield may happen if you cannot select the appropriate component crops. Delayed liquidation, as you know, any timber crops requires at least 8 to 10 years to harvest. Some report of berry caterpillar on soybean under poplar on some allelopathy. And since agroforestry is a polyculture and accommodating more than 8 species within 100 or 200 meters, so cultural operation and particularly machine movement is really problem. And some permission from it depends on government to government, but permission harvesting or disposal, there is some legal issue from countries to countries. And now here we are going to represent our case study of restoring degraded land and dry land through agroforestry. Here it is the central India and the tail end of the Chutnarpur Plateau, where it was a social harmony between nature and the tribes residing there in the forest. Due to policy-driven changes from cultural ecology to political ecology in the form of converting forest land into agricultural land in the river watersheds. Second, compromising the biodiversity during British period with accommodating more fast-growing timber species, reducing biodiversity in the forest. And third, after the independence of India, taken over of the entire forest area by the government without settling the right of the forest fringe dwellers, resulted the virgin tropical moist deciduous forest into degraded dryland. In this area, in this degraded dryland, we have done a decade-long experiment from 2009 to 2019 and compare 4 production systems Gmelina representing the forestry, mango representing the horticulture, pigeon pea representing the classical rain-fed agriculture, and integrating Gmelina, mango, pigeon pea. Gmelina 400 plants per hectare, mango 100 plants per hectare. In agroforestry system, we are accommodating 300 Gmelina along with 100 mango. And after 10 years, the result you can see the 2.1 land equivalent ratio and 3 times higher net return than that of agriculture or forestry, and doubling the income in comparison to horticulture. Because of the regulatory services in the form of indicators like higher dry biomass recycling and higher net energy production in the agroforestry system. And this become possible only by generating, supporting some ecosystem service indicator. In the 10 years, pH has improved from 5.2 to 6.48 with improvement of soil fertility in the form of organic carbon, available NPK, and water stable aggregate water holding capacity, microbial biomass, favorable enzymatic activities have also improved in the agroforestry system. Now, earlier we have found that only different category of agroforestry ecosystem service has been compared. Now, in our case, we have proposed a new ecological index to the globe, the comprehensive evolution index, integrating all the ecosystem services. We have shortlisted based on principal component analysis. Then we have calculated with transformed value of this ecosystem service with factor loading values of the PCA component. And these are the components we have shortlisted: net present value, net energy, biomass, greenhouse gas emission, carbon sequestration, soil pH, soil organic carbon, water holding capacity, water stable aggregate, dehydrogenase activity, microbial resilience index, Simpson's diversity index of earthworm. And here you can see the higher ecosystem service multifunctionality in agroforestry system.
Professor Biswas, your time is getting shorter. I believe.
Yeah. I will take 2 minutes, sir.
Okay, very good, very
Thank
good.
You,
we are enjoying your presentation indeed.
Sir, I will finish within 2 minutes. Sure,
thank you.
So here the multifunctionality of ecosystem service, you can see we have taken all the best of these forestry, horticulture, and agroforestry, agriculture integrated into agroforestry. And here is the regenerative capacity. So far, composite evolution index, it is the regenerative capacity of the agroforestry system is 5 times more than agriculture, 3 times more than horticulture, and twice than that of forestry, having highest level of synergy among multiple ecosystem services. Here is the degraded dryland in 2009, converted into fertile one with a improvising of provisioning, regulatory and supporting services at our Jhargram situation. So way forward, we can identify site-specific regenerative agroforestry models, and scaling up, we can take help of AI and ML also. Integration with climate action plans and regional collaboration under SARC is very much essential in this way forward. And I would like to conclude that agroforestry is a key to regenerative agriculture, which supports not only livelihood, but ecology and climate goals too. So it is the right forum which can initiate supporting policies and researches. With this and for the opportunity, I again thank Director Sir for this unique opportunity. And I am learned so much and still learning in this August meeting, sir. Thank you.
Thank you, Dr. Biswas. Professor Biswas, you are from Bidhan Chandra. It's very quite familiar with Bangladesh scientists, Bangladesh workers. So thank you for your nice presentation indeed. And you covered a lot of very excellent issues, focusing land degradation and tree selection. And you talked about ecological index. So I think
Not with us, sir, so far as that.
Okay, Dr. Benukar Biswas, please.
Yes, sir.
Professor
Let me
Dr.
share
Benukar.
the concerned. Is it visible, sir?
Yeah,
The
yeah,
Slide?
yeah, it is visible.
Samim sir, thanks for your kind words and appreciation. And it is the greenhouse gas. Greenhouse gas emission is also the highest in this Gmelina mango pigeon agroforestry system. And it is contributing negatively when we are calculating the index. It's not that agroforestry system is producing less greenhouse gas. It is producing the maximum. If you see the spider chart, lowest is the from forestry, Gmelina system. Then agriculture and mango, since mango is dominated with use of chemical fertilizers and some pesticides, so it is contributing some greenhouse gas emission too. Thank you for your nice question, sir.
Okay.